All right, this EGR 1010, everybody here? Good afternoon. Good afternoon. Good afternoon. That's better. Just want to make sure you're awake. All right, I guess you've not seen me before. My name is Dr. Ratan. I'm a professor in the Department of Electrical Engineering. I think you got an email from Dr. Kingbal, right? I'm filling in for him today, and I'll be back a few other times when he's traveling. You know, he's a dean, right? So you're lucky to have him. And generally, deans don't teach, and he really wants to teach this course. So he's traveling, and I'm trying to help. You probably seen my name on the book. I have been working with Nate, Dr. Kingbal, since we started this course, so I'm familiar with this course. I will teach during the spring semester. He's teaching in fall, and I'll teach in spring. So any question you have before I start? I brought goodies for you to see what we are talking about. Matter of fact, I'm teaching a course in robotics. Okay, so what you're doing these days, really what you will be, if you take the robotics course, you will see that. So you are far ahead. If you understand what's going on, you will understand robotics. Even though we are talking about planar, we're talking about plane only in this class. Generally, in robotics, you talk about three-dimensional. But we still do that same thing in that course for them to get familiar, okay? And then we do the real robot. But anyway, if you don't have any question before I start? Okay, so he told me where to start. And he asked me to start with and he already did start on that, but I'm going to repeat a little bit of that, is the inverse problem, right? In robotics, we call it inverse kinematics. So the problem is, you do the direct kinematics before, direct problem, where you were given the angles, and you want to know the position, right? So let's look at this robot. I'm going to put it right there. Okay, so this is not a real robot. This is you may have seen that in Toys R Us or whatever. So this is like a real robot, but we're going to make it a problem like you're dealing with. So think of this robot has two joints. That's what you're talking about, right? So I can make my arm as a robot too, right? You have this joint, shoulder joint, and you have an elbow joint. So instead of using my arm, I thought I'll bring and show it to you. So this is, forget about the rest of the thing. Think of these two links. This is the shoulder joint, which moves like that. I can go around, right? And then I have an elbow joint, which goes like this. Okay? So what you learned earlier, that there is an XY coordinate system, right? So I brought something like this to show you. So think of this like that, okay? So I'm going to straighten out this thing. And this thing been abused, so it's hard to get them really straight. So this is my x-axis, and that's the y-axis. And you were also told that the angle of the joint 1 with variable is theta 1, right? And for the joint 2, which is the elbow joint, is theta 2, right? So let me go on the board and draw this coordinate system. So this is the x-axis. That's the y-axis, right? Okay, so if I make this straight there, so think of this joint here. There is a joint here with the shoulder joint. right? Right now, the way I have it, that angle theta 1 is 0, right? So let's say this is my, if I just simply have one link, that was look like, right? Right? And if I make the second joint right here, you can see exactly that. That's my joint here, and that's the elbow joint. And if I make that variable theta 2 here, that becomes the tip of this row bar, right? And that's exactly what you see. So think of this as my tip, right? I can pick up, I have an end effector there. I can pick up things with that, right? Now what I do is I change, I vary this angle. You are also told if I go counterclockwise, I have the angle to be positive, right? If I go clockwise, did I say counterclockwise here, that angle is positive, that angle is negative, right? So what I'm going to do is twist this joints there to make it something different. So let's say I move my, remember, if I go this way, that angle is positive, right? So let me make the shoulder joint, and let's say I'm here. So that angle now, with respect to that, is positive angle, right? So if I change this now, let me draw that with the different color. If I change this, if I twist, I twisted this, right? And I went here, so that becomes my theta 1, right? Agree with that? That's this angle here. Now, you were also told that the way you did it, so this is my elbow right here now, right? There is my, right there, right? So if you see over here, I did not change theta 2. So that's why it looks like this. This is the dotted line here. So theta 2 in this case is 0, right? Theta 2 angle is 0 if for this line, right? Agree? So if I do that, if I draw that theta 2 equal to 0, that looks like this. Oh. Right? So that will be my tip of the row bar, right? Now, if I want to change the angle theta 2, and I tell you it's a positive angle, right? And you're going to start from there, right? And again, same counterclockwise positive, clockwise negative, right? So if I put some angle here now, that will be my theta 2, right? And that become the tip of the row bar, right? Okay, you have done all that. So let's do that here. So if I now, so this is my elbow joint, right? So if I go, okay, right there, that is what I have there, right? And I can pick up this thing, okay? So once I have theta 1 and theta 2, you give me an angle, okay? And make sure you have right angles, positive and negatives, right? In this case, both theta 1 and theta 2 are positive, right? Okay, and I can find the position of the tip of the row bar, and we call this to be pxy, right? pxy. And I can move it around in space. Remember, the length of the link are fixed, right? What is varying are the two angles, right? And I can go anywhere in the plane, right? Anywhere, of course, within we call workspace. You can only reach because of how long my length are, right? I can go anywhere in the plane. In a real robot, we also have a z-axis, and we can go in space, three-dimensional, okay? So in this case, we restrict ourselves to only x and y plane, basically, right? Okay, so I have now, you give me any angle theta 1 and theta 2, whether they are positive or negative, I can cover a plane, right? Okay, so I can find pxy. But in robotics, that's good, but real problem is, now if I tell you that I want to pick up, I have some object here I want to pick up. I know the position of that, right? I can have a camera there. In robotics, we have cameras which give you the location of the object. So I give you pxy. So this will be given. And how do we pick up? You'll have to what? You have to find the angle. You have to find the angle theta 1 and theta 2. So given that, find me theta 1 and theta 2. And then I have a control system. If it's all done autonomously, you have a control system and take the robot there and pick it up. That's called the real problem in robotics. That's how we do pick and place. Okay, so there is a camera there. There is an object there. It knows what the position is. I have a program in there, which is basically the inverse kinematics problem. I already wrote the algorithm. Then it goes and pick it up and take it wherever you want it. So let's solve that problem. Let's suppose you are given the position of this object. And let's do the problem you have in there. That says it's 12.6. This thing is 12.6. Okay, the units are not going to be matching the way I drawn it, but whatever that is. So what that means, 12.6 mean what? It's the x and y, right? 12 units in the x direction, 6 units in the y direction. And we know that is, so if you have that, that is 12. This distance is 12, right? So this is the x, and that's the y, 6. Okay, I'm sorry. I do that wrong. This is not it. That's it. Okay? Is that clear? So that's given to you. You help me find theta 1 and theta 2. That's the problem. Okay? So that's what I'm going to do. Yes?
Don't we need the lengths of the...
Okay, yes. Yeah, that's given in thank you. Length is same, both cases. This is 5 square root of 2. Now you may say, why that? Well, we just want to make the calculation a little simpler, okay? Whatever the length is, you can call L1 and L2. That's fixed length, right? The length, this length, L1, that length, L2. Okay, whatever that is. So given that, the length, L1 and L2, given the pxy, find me theta 1 and theta 2. Any idea? You have the notes already, so any idea? What should I do? Okay, if you read the notes before, or actually he did it, right? All right, so how do I find that? Theta 1 and theta 2. Anybody? Come on. Nobody? Go ahead.
The theta 1, you can create a right triangle.
Say it again, please.
Right triangle, the first one, theta 1.
Okay, so he says make a right. Oh, I made a mistake here also. Okay, that is 12. This is not. So this is what confusing me. So that's 12 and that's 6, right? So that x is 12, that y is 6. So if I make a mistake, please speak up, okay? All right. So, and I was told make a right triangle. So this is, if I can draw a straight line, that is a right angle triangle, right? So I have that triangle. What do I do with that? What does it give me?
Two sides find
Say it again, please.
You have two sides, find the third.
Find the third. So he says we know this, we know that, we can find this. So let's find this, what that is. What is it? Well, you all know that it is this 12 square plus 6 square square root, right? Agree? And what will that be? Is that 180 square root of that? 12 square is 144, right? 6 square is 36. You add 144, 36 is 180. All right, so we have that. So what? Didn't give me anything, angle theta 1 and theta 2. What do I do with that? What do I do now? My idea is to find this angle and that angle. So what I have here, let me redraw here. So I have this, I have that, and I have that, right? If I take this triangle, right, we know this is square root of 180. This is 5 square root of 2, right? And we know this angle is theta 2, and theta 2 is positive angle, right? All right, knowing that, help me find theta 2. Law of cosines. I heard law of cosines. Anybody know what that is? So let me make this, I think in your notes, he calls it A, we call it ABC. So let's call this to be A. Let's call this to be B. Let's call this to be C. And this angle is 180 minus theta 2. Do you agree with that? All right. Knowing that now, he said law of cosines. Well, tell me, help me write that. Anybody? Scared? What?
Root 180 squared.
Okay. So he's saying that square of that, okay, equal to
5 root 2 squared.
5 square root of 2 square
minus 5 root 2 times 5 root 2 times the cosine of A.
cosine of what?
The angle opposite A.
Which angle?
180 minus theta 2.
180 minus theta 2?
Now it's 5 root 2 squared plus 5 root 2 squared.
All right, there is a mistake here. He's saying there should be another, let me do that here, put that here on this side. All right, now is correct? Do you agree with that? Okay, I do. Okay, so what, how does it work? Okay, so always, this is the angle I want to find. Okay? So if I know this angle, I have theta 2, right? So it's always you go to the side opposite to that. Okay? So you look right opposite to that, and that's what square of that. Yes?
The 5 square root 2 that's not squared is just supposed to be a 2.
Yeah, 2 times.
Okay, so this is wrong. Is that what you're saying?
So that's supposed to be squared, but the 5 square root 2 to the left of it is just supposed to be a 2.
This one?
No, the one,
That one is supposed to be what?
no,
Right there.
that's just supposed to be a 2.
There's supposed to be 2 times that.
Now you agree?
Yes.
Okay. All right, that's correct. Okay, so let me finish this, what I was saying. So you go right across that, right? In front, on the other side, and square of that, right? And then equal to the square of the adjacent sides. So in this case, this 5 square root 2 square, right? Similarly that. So in this case, let me write that, what it is. So it's a square equal to b square plus c square, right? Minus 2ab cosine of 180 minus theta 2. Okay, that's what law of cosine is. So again, A, B, C. Okay, so A square equal to B square plus C square minus 2 times the product of this, right? Yes,
You used the word adjacent.
adjacent.
Which one?
Okay, adjacent to this side and that side.
Right, you have the 180 minus 80 angle is adjacent to both of those sides.
Yes, that's what I said, two adjacent sides.
Okay.
So this side is B square, this side is C square. Okay, so the square of the two adjacent sides, right?
Yes, sir.
Okay, and then minus 2 times the product of those two sides times the cosine. And that's what you have here. All right, so what you have here, let's simplify it. So this is 180 equal to, what do you have? 25, right? Times 2, 50, right? So you have 50 plus, take this one also 50, right? And then you have what? 50 here times 2 is 100 cosine of 180 minus theta 2. Right? All right, so let's simplify that. That's 100, right? If you add these two up, so it's 180 minus 100 equal to minus 100 cosine of 180 minus theta 2. Right? So if I simplify that, that's 80 minus 100 cosine of 180 minus theta 2. Right? Now let's divide both sides by 100. Get rid of that here. So you have what? Let's divide minus 100. Just leave a minus sign there. Or you can say 0.8 is equal to minus cosine of 180 minus theta 2. All right, so I still don't have, we can use that to find 180 minus theta 2. But could you tell me what this is in terms of theta 2? So let's look at what we have here. So we have, so we say this is 180 minus theta 2, right? So this will be theta 2, right? Agree? So what is the relation cosine of this? What is, you know what cosine sign is? If I take this triangle, if this is my angle theta, you know this is cosine, this is sine. If this is 1 there, right? Agree? Right? If that's 1, you have the base is going to be cosine, right? And vertical is going to be sine. So based on that, what will be that? If I take that, that's let's take simply a 1 there, cosine of theta 2, right? So it's in the negative direction, right? Right? So can I say that cosine of 180 minus theta 2 is equal to minus cosine of theta 2? Because in the negative direction, right? Right? Okay. So if I use that fact over here, so there is a minus sign already there. So I can say this is minus cosine of theta 2. Right? This is a minus sign. That's minus cosine of theta 2. So I have cosine of theta 2. So we found that cosine of theta 2 is equal to 0.8. Right? So let's come here and look at that. So if I have cosine of theta 2 equal to 0.8, can somebody tell me what that is? What would that be? You can use your calculator, right? What will that give me?
36.87.
What is that?
36.87.
36.8. How do you define that? You can inverse of that, right? Inverse cosine, right? Will that be the only solution? Will that be only solution? What other solution is there? Negative. So you can have a plus or minus. So cosine of plus 36.8 degrees is going to be what? 0.8. Cosine of minus. So which one does I take? What would I take? What would I take? Positive. Why? Because we know this angle is positive. Because we know this angle is positive. So we will pick the positive sign. Why aren't we picking the negative sign? Why aren't we picking the negative sign? So in robotics, you take all the solutions. Okay? To go to a point, there may be many solutions. And why do I pick all the solutions? Because you may have, now this is in robotics, okay? You may have an object, okay, somewhere. So this solution may not be good, but another solution may be good. So it's a very good idea to keep track of all the solution. But what is that solution? In the case of robotics, what will that be? So I know I have plus 36.8 degrees, right? So this angle here is plus 36.8 degrees, right? And so corresponding, we'll find the angle theta 1, right? All right? Well, let's look at, I want to go to the same point. Let me twist my arms here. Oh, I'll keep that same place. So I can go to the same point. And now, if I go here, now my angle is negative. Right? So I can have a positive or negative. But what happened? I had to change my angle theta 1, right? If I go over there, my theta 1 was that angle, right? So let me redraw this. Let me redraw this figure again. So let's say I'm going to draw a little bigger here. This is x, that's y. Okay, so I had theta 1 and theta 2, right? So this is 36.8 degrees, and let me draw it better, a little bit more. So this is 36.8 degrees. And that's my P, XY, 12,6, right? All right? Now I can reach the same point. Okay, so this is my theta 1 to be positive. I can reach the same point by doing this. Well, I need to maybe go a little bit, length may not be same, but anyway, so this is my angle, 30, like that. So what in this case, this angle is minus 36.8 degrees. Same angle, but negative. Now it's elbow down. See, we call this, when you have positive angle, we call elbow up, right? And the other way is elbow down. So this is elbow down because you are going in the what? Clockwise direction, right? When you go clockwise direction, you have elbow down. This elbow is down, right? Other way, elbow was up. So you have basically two solutions, multiple solutions. You have two solutions. But according to theta 1 equal to 36.8, you have a different value of theta 1 compared to the other one. Okay? And we're going to find that. Okay, now, generally, it's not in your notes. Generally, it is a good idea never to use inverse cosine. Okay, so here is what's happening. Here is the real, and this will be very helpful when we talk about the vectors. So we have, this is 0.8, right? I told you, horizontal is cosine, right? So what are the two solutions we are getting? We are, if you have on this side you have, so this will be 0.6. Right? If you have 0.8 and 0.6, that will give you an angle of 36.8 degrees, arctangent, right? If you take the tangent of that, you'll do that. So other one is this. Let me make it a little smaller. Minus 0.6, and that's minus 36.8 degrees. So same value cosine. What is the other one? Sine. So if you have both sine and cosine, you will know the exact value of theta, right? So you need to know the both. If you have one value of sine, one value of cosine, guaranteed to have one value of the angle. But if you only have one, other one is plus and minus, right? So in this case, sine of theta 2. Why is that? Let me show you that. So we know this integral identity, right? Everybody know that, right? Sine squared theta plus cosine squared theta equal to 1, right? So we know cosine. What will be sine? So let's solve that. So sine squared theta is equal to 1 minus cosine squared theta, right? So what will be sine theta? Anybody? Square, right? Square root. Is this correct? Is this correct? But we are missing something. Plus or minus. Right? Plus 1 minus cosine squared theta, square root, square is going to be that minus 1 square is still positive. All right, if I use this here, that's how I got 0.6. So if we know this is 0.8, right? So 0.8 square is 0.64, right? So we know 1 minus 0.64 square root, right? Right? Which is going to be 0.36 square root, which is going to be 0.6. So this is plus and minus. So if cosine theta, if cosine theta is equal to 0.8, sine theta better be plus or minus 0.6. Right? Right? And now you can use tangent. Okay? Tangent of theta is ratio of sine over cosine, right? And it's going to be plus and minus 0.6 over 0.8. So there are two. So if you take the inverse tangent here now, theta will be plus and minus 36.8 degrees. So that's what we do in robotics. We never use inverse sine or inverse cosine. Okay, you always use inverse tangent because you need to know both value to be sure what value. So you can get then multiple solution, right? Otherwise, if you say that, otherwise I need to know it's positive or negative, right? Okay, it's when you have so many different links, we generally have 6 degrees of freedom, 6 links, 6 angles. Okay, in space, X, Y, Z. So we don't really can see the picture. Okay, picture in space, it'll be hard to do. So math, you have to rely on. Okay, so never use. It's okay here because you know it's elbow up. So you know theta 2 better be positive in this case. If I've drawn it other way around, you will know it's negative angle of theta 2. You will take a negative. But if you are finding all solution, you know cosine of theta is 0.8. You find sine theta, which will be plus or minus 0.6, and finding the angle using the tangent. Okay? Is that clear? It will come very handy later on. Now let me tell you, I'm going to even change that. It's not a good idea to use arctangent. You should never use it. You will go wrong. Okay? If you go to MATLAB, and later on in the next chapter, we have the notes, it says arctangent 2. Okay, so tangent will be good if you're doing arctangent. It will be good if you are in the first or fourth quadrant. It will give you the right answer. But if you are in the second or third quadrant, you will get the wrong answer. And we'll talk about that when we go to the later on vectors and also in complex numbers. Okay, it's very important. Arctangent is known as two-quadrant arctangent because it's good only for the first and fourth quadrant. Atan 2, and if you write, go ahead and try that. Go ahead and try looking at that Atan. Okay, look at, go home, use MATLAB. You're using MATLAB, right? Okay, so look at minus, well, I can do here, let's say you are in here, so you will have, let's say minus 0.6 over 0.8. Okay? If you do the arctangent of that, right? So you are actually here, right? Because negative 0.6, I'm sorry, negative 0.8, let me put it here. 0.8 is negative, right? If cosine is positive, you are in the first or fourth quadrant, right? You'll be okay. But if cosine is negative, okay, and once you divide it, sine is lost, right? This answer is going to be minus 36.8. If you go to your calculator and divide 0.6 by minus 0.8, it doesn't know whether it's dividing minus 0.6 over 8 or 0.6 over minus 0.8, right? And you're going to get the wrong answer. But if you keep A tan 2, so if you do so do that first and do the A tan 2. But when you do A tan 2, your syntax is not that. Okay, first you will get what? Sine, right? Sine is equal to 0.6. Cosine is minus 0.8. Now you're keeping the sign. It knows which quadrant you are in, and it will find the angle as what? It will give you the angle. The real answer is 180 minus 36.8 degrees. Go try that, okay? Okay, so but A tan, you give the ratio, you divide it, and then you find A tan. When you do A tan 2, you say sine theta, comma, cosine theta. You do not divide. If you divide, you lost the sign, okay? And again, we'll talk more about that later on. Okay, anyway, I just got distracted because to me it's very important because I teach robotics and we find the wrong answer if you don't do that, okay? So you always use A tan 2. I never use. A tan 2 will give you right answer, doesn't matter. It's called the 4-quadrant arctangent. A tan 2 is called the 4-quadrant arctangent. Okay? Whereas A tan is known as the 2-quadrant. It's only good if cosine is positive. If cosine is negative, it will give you wrong answer. Okay, if you are in the second or third quadrant. Okay, so I know if it's theta 2 is positive here, right? So we know the angle theta 2, right? We know it's elbow up, right? And we know it is going to be, you need to know it's elbow up, okay? In this case, it's elbow up. So 36.8 degrees. How do I find theta 1? Okay, so let's see if we can find the value of theta 1. Okay? All right, so let me redraw again. So we have we know that this angle is 36.8 degrees. Whatever. That's P here, which is xy is equal to 12,6. And I want to find this angle. Okay? Any idea? We know that this is that, and this is that, and this is that. Law of sines? Law of sines? Why not law of cosines? What? You can, okay. So, if I use law of cosine or sine, you will know this angle, right? Right? But I need theta 1. How do I find theta 1?
Divide 36.8 in half, you get the lambda there.
Find the whole angle by using the quads.
Okay, so I'm told that you find theta 1 plus alpha is equal to what?
The tangent of 6
Okay, so you can, in this case, since you are in the first quadrant, you can use arctangent, or always use a tan 2 what? 6 comma 12 or 6 over 12, okay, in this case. And if you do that, this angle is going to come out to be 26.57 degrees. Am I right? Did I do it right? Yes. Okay, so 26.57 degrees. That's angle theta 1 plus alpha. Right? So we still need alpha. How do I find alpha? Okay, I'm told you can use law of cosine or sine. Yes?
You know, since both of the lengths are the same, the alpha and the angle across them are the same. So if you take what you got for the remaining and subtract that.
Very good. So you're talking about law of sines, right? So let's go ahead and use law of sines. Let me get rid of this, since I don't want to write below that because some of you may not be able to see it. Okay, so let's use law of sines. Okay, so let's go ahead and use that triangle. Let me put that triangle again. Okay, so we will call this to be, we call this C, let's call AB, and let's call this angle, whatever this angle, let's use exactly the same triangle instead of worrying about doing that. So we have, right? We have something like that, right? We know this, we know that, and we know this. And we know this angle, right? And we want to find this angle. And what is this angle? 180 minus 36.8 degrees, right? So whatever this comes out to be, 143.2 degrees, right?
Yeah.
Okay, so let's use law of sines. Okay, so it's always, let's say I want to find this angle sine alpha divided by the side opposite to that, right? Right? If when you use law of sine, you have to know one of the angle and two sides. Okay? Whereas you can, if you know all sides, you can use law of cosine. Okay? All right? So, and otherwise also, I'll talk about that. Since I know all sides, you can find alpha by using law of cosine. We'll do that later on. And we know this sine of 143.2 degrees divided by this, side opposite to that. So whatever angle you're taking sine of, you take the side opposite to that. And from there you can find the angle of sine alpha will be what? So multiply both sides by this. So it will be sine of 143.2 degrees multiplied by 5 squared root 2 divided by that. Yes?
Since the lengths of the triangle are the same, can you just divide the 36.8 in half at each angle?
But it may not be. I'm just doing if it's different,
Okay.
then you can do that, right? Okay. So in this case, it happens to be. Okay? All right. So and whatever that comes out to be, you can find that alpha comes out to be 18.45 degrees. Okay, that's what it's going to come out to be. And so from there now, you can use theta 1 is equal to, take alpha on the other side, 26.57 minus 18.45 degrees. And it comes out to be 8.12 degrees. And that's the answer. So this is 8.12 degrees. And that's the answer. This is how you solve it, okay? Basically what we have, the reason it is problem is in trig section, because all we are learning from here, what? Law of sine, law of cosines. That's by using that, you can solve this problem, okay? Along with that, we need to know trig a little bit, okay? Now, let's find out if I would have done elbow down solution, if I had this solution, we just found this value, right? All right, so let's say that instead of that, I want to find this solution. Okay, again, we know this is 180 square root. That's that. That's that. Right? And we have 6 over here, 12 over here, right? You agree? Okay, so how would I do that? In this case, what is this angle? This angle is theta 1. Right? So this is 12, right? And this angle is alpha. Right? So again, we know the total angle, we know this angle, right? Is what we think arctangent, that's what we found here, 26.57 degrees. 26.57 degrees, right? Arctangent of 6 over 12, right? So in this case, theta 1 is going to be what? It's going to be plus, right? Theta 1, 26.57 degrees plus alpha. Over there, we had theta 1 plus alpha is 27.5. In this case, so you have to change the value of that. So we find the value of alpha. Alpha should remain the same, right? Alpha is not going to change. You agree? Alpha will be exactly the same because this angle is still 143.2 degrees. Right? It's exactly the same triangle, right? So alpha we found was equal to 18.4. So this is going to come out to be 45.02 degrees if I added it right. Almost 45 degrees. So we'll have to change the, did I do it right? So it's theta 45 degrees or 40.02 degrees, right? So look what's happening over here. In this case, this angle theta 1, right? Its angle is more, right? Whereas other angle is same. Now if I go the other way around, this angle is much smaller, right? That angle is this over here. Let me do it exactly over here. So this angle is what we did 8.2 degrees, right? So this way is 8.12 degrees. That way is almost 45 degrees. So depending upon, so two solutions are what? One solution is 18.12 degree theta 1 and corresponding value of theta 2 is plus 36.8 degrees. That's one solution, right? The other solution is 45 degrees, 0.02 if you want to call it, minus 36.8 degrees. So we can reach the same point in space, not in space, in a plane, right? We have x, y only, right? By two ways, right? That are the two solutions. And that's what basically we have. And that finishes this chapter, trig chapter, right? Any question you have? So what have you learned in this chapter? Basically, let me start from backward. Law of sines, law of cosines, right? You learned sines and cosines. We talked about tangent. We also talked about a tan 2, right? Okay? So that's basically what you have learned in this chapter. So you should be able to do any trig now, what we do in other classes, trig classes. Okay? All right? All right. So I'm going to, any question on this chapter? So the next chapter, we finish at 4:50, right? So we have about half an hour. Okay, so let's talk about now. You need a break? You're okay, right? Okay. So next chapter is vectors. Two-dimensional vector, right? Again, we are not going to the third dimension. In this class, we only stay with 2 dimensions, right? Okay, so let's go ahead and start talking about, by the way, we are going to take, since you've been taking 1-link and 2-link robot, right? Even though we don't use vector, you will not see vectors being used in robotics. But just to stay consistent with the problem, we decided to take the same problem and represent the robot as a vector. Okay, again, remember, we will not, never, you will, if you go to robotics, you will never use a vector. You will do what we just did, okay? But just to continue with the same problem, we're going to use the 1-link and 2-link robot, okay? So let's see if we can represent a 1-link robot. We start with 1-link and then we'll go to 2 links. 1-link robot as a vector and represent that vector in the vector notation, okay? So again, we will take x axis and y axis, okay? Because we talked about 2 dimension, right? And let's take a 1-link robot, okay? And we will define that as a vector now, and we'll put a vector sign on top, arrow sign. Okay? All right, before that, you also represented the position, right? But now we are going to put that as a vector in the vector form, okay? All right, so to do that we have, so basically it says I can reach there by going so much in this direction, right? And these are called the principal axes, right? So let's say I go px. Px is the distance in this case, or magnitude, right? In the x direction, and then py in the y direction. So if I want to write p as a vector, well, I know it's a px, but how do I put the direction, x direction and y direction? Any idea? Do you understand my question? How do I write mathematically the direction in x direction and y direction? Anybody? I and j. I and j, that's what people use as notation. But what they mean? What is I and j? What's I and j are called? What's I and j are called? All I want is the direction. I don't want any magnitude yet, right? I want the magnitude to be equal to 1, right? All I want to show the direction, right? So it's called the unit vector. I is called the unit vector which has a direction x. And j is the unit vector in the y direction. Okay? So once you say I and j just represent the direction. Right? If I multiply them, okay, I get the magnitude to be equal to px, right? So this is how we generally write it. So when you draw that, you put in here direction over here, I. By the way, in the book we use vector like that. In your notes, that is written like this. Either way is fine. Okay, that's generally how people write that also. So it doesn't matter how you want to put this in there, and I'm going to carry on like that because that's how your notes are. But if you put an arrow on the top of that, that's perfectly fine. Okay? So I and J represent, I represent the x direction, J represents the y direction. Now I can write it, right? So I can say Px, and I'm used to writing, I'm going to just continue with that. Okay? If you want, you can write it like that. So this is my I, and Py, and that's a unit vectors, right? So that's the representation of a vector P, okay, as a two-dimensional vector. Any question on that? That's the vector now. I'm representing a one-link row bar, right? So I already talked about I is the unit vector in the x direction. Yes.
So is I and J like the actual symbols for vectors, or are they just?
It's unit vector.
Okay.
It's a unit vector.
Okay.
It has a magnitude of 1,
Okay.
direction in the principal axis x.
Okay.
Okay? Okay, and where x and y, px and py are the x and y component. Okay? All right, so let's put in now. So this is called the Cartesian form of the vector, right? Because you're using px and py. Well, let's look at now polar form of that. Let's say this is my p theta, and that's my magnitude p. Okay, so p is a vector which has a magnitude of p and angle of theta. Okay, so there are two forms we can write a vector. Okay, this, so some people write this instead of writing arrow there in the book, you may see boldface, okay, for the vector, and simply without the boldface as a magnitude. Okay, so whatever way you want to see that. So this is called the polar form. Okay, and that's the other one is called the Cartesian form. Okay. All right. So let's now write. Let's start with the problem. Let's say I gave you the vector in the polar form. Let's say this is 0.5, and the angle is 30 degrees. Okay, that's given to you. So the vector is defined now in the polar form, right? So what do we have here? 0.5 angle of 30 degrees. That's what I'm giving you, right? I've given you the polar form. So what I'm talking about now is conversion from the polar form to the Cartesian form, right? So what I want to do is find the x and y component, right? Once you're given the polar form, I can write that in the other form by doing that, right? So like that's going back to trig again, right? Tell me what is px. How do I find? Given this, given that, how do I find px? Cosine, okay. So I told you this is always cosine, that's always sine, right? So this is 0.5 times cosine of 30 degrees. All right, should already know what is cosine of 30 degrees. Come. Do you remember the table?
Root 3 over 2?
Huh?
Square root of 3 over 2?
You don't have to go to a calculator for that, okay? You should know the basic angle. 0, 30, 45, 60, and 90 degrees. You should, you know, if you know these, things will happen pretty quickly then, okay? All right, then you can approximate what the approximate value is going to be. If you are between 30 and 45 degrees, what should be approximate value, and so on, right? All right, so, and once you know sine, cosine is automatic, right? It's the reverse, right? Remember the table? You say, let me repeat that. All right, so if I have So this is my theta, right? So 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees, right? And if you look at the table, this is my sine of theta, right? Okay, remember I have this 0, 1, 2, 3, 4, right? So go from, and you know it cannot be greater than or less than 1, right? Sine and cosine can never be greater than 1 or less than -1, right? So you do the maximum is 4, so you divide by 4. And then find the square root of that. And you have it. You should never forget that, right? Right? So you know, if I have sine of 60 degrees, that's the square root of 3 over 2, right? Agree? So this is square root of 3 over 2. Square root of 4 is 2, right? Okay, again, it'll be a good idea, instead of worrying about going to the calculator, basic square roots. Square root of 1 is what? Square root of 2 is what? 1.414. Again, know that. I think it's because you're going to be using it again and again. What is square root of 3? 1.732. Okay, those are basics. And you know square root of 4 is 2. Okay, so we know, if I want to know this is 1.732, so this is going to give me that, right? 0.866. Okay, it's a good idea to know this, okay? It's not too much to ask, right? So when you're doing the cosine, you go the opposite way, okay? Start from here. This, by the way, this is 1. This is 1. This is square, that next one is square root 3 over 2. By the way, this is 1 over square root 2. Or you can also write this square root 2 over 2. It's same. Sine and cosine of 45 degrees is same. Right? Because right in the middle of that. And that's what? 1 over 2. And that's 0. Okay? So those are the basics. It should be at your fingertips. Okay? You should be able to just spit that out very quickly. If you know this table, put that in your head. You put 0 to 4 and then divide by 4 square root. You can do that quickly, right? So what is cosine of 30 degrees? Is that 0.866. So 0.5 times 0.866. Okay, multiply that. It comes out to be 0.433. Okay? Got it? So that's Px. What is Py? Okay, it's going to be sine. And sine of 30 degrees is 1 over 2. And this is going to be 0.25. So you know Px and Py's. And now we have Cartesian form, okay? Px is equal to what? I'm sorry, P is equal to what? Px, right? Px is equal to 0.433 in the x direction, or vector either way, I hat or I arrow, right? Plus 0.25 j. And you have, and by the way, units, let's say if I give you 0.5 meter over here, and you can put it here, the answer as meter, okay, m. If it's centimeter, it'll be centimeter, right? So the units goes with px and py, right? That's what the distance is. I and j are unit vectors. All it tells you, that's the direction. X direction and y direction. Okay, so what it is saying is I can go to this point by going in this direction, right? Or I can go in this direction and that direction. And those are the principal axes, right? Is that clear? Okay. You can go from, so now here we gave you the polar form, you do that. But what if I gave you the, and I'm going to change it, okay? This problem, purposely, I am changing what is given to you, okay? I'm going to go from the Cartesian form to the polar form. So let me give you this problem. It's different than what you have in the book or in the notes. So what I'm going to do is say minus 0.8 and 0.6. Okay? So find me the vector p in the polar form. Are you with me? So you are given what? So you're given p to be minus 0.8 I, right? You agree with that? It's in negative direction, x direction. So it's minus 0.8 plus 0.6 j. Positive in the y direction. Do you agree with that? You do? Okay, so help me find that in the polar form. So let's find the magnitude first. P. Let's find P first, because to represent that in the polar form, I need to have that, right? Agree? So what is P? The magnitude of the vector. Okay, so we know this, we know this. This distance is 0.8, that distance is 0.6. Okay? So what would be this? 1, right? 0. So basically this is 0. You can call minus square if you like. You can do that. I wouldn't worry about minus sign there because it's going to be square anyway. It's that, right? Okay, so it's 0.64 plus 0.36. Magnitude P is always going to be positive. It cannot be negative, right? You know that, right? Distance cannot be negative. Okay? And what is that equal to? 1. So that is 1. Agree? How do I find the angle theta? Help me find the angle theta. So first of all, before I, just a minute. What is theta here? How do I draw that? How do I draw? What will be the angle theta? It's always from this axis. It's always from the positive x-axis. Remember that, okay? When you represent the angle, it always from the positive. Remember when you did the previous chapter, that's what you defined. This is, remember we talked about positive in this direction, from here, negative in this direction. So the angle theta we are looking for is this. Right? So how do I find it? I'm going to talk about a couple of ways of finding it. First of all, if you use the arctangent, you're going to go get the wrong answer, right? What you're going to get from that arctangent is this angle. That you can use the arctangent. 0.6 over 0.8. Remember we did 36.8 degrees? That's why I took this problem. Okay? That 36.8 degrees. Now, if you use A tan straight, right, it'll be 0.6 over minus 0.8. You're going to get the angle theta to be minus 36.8 degrees, which will be wrong. Can anybody tell me, I'm sure you did that in high school, what this angle called? Reference angle. Reference angle. This is called the reference angle. Okay? So reference angle is 36.8 degrees, and now this angle is 180 minus 36 degrees minus 36.8 degrees, which is 142, 140, 143.2 degrees. Right? So this answer is equal to 1 angle of 143.2 degrees. So one way to do that is to always find the reference angle, and from there find the angle. The other way to do that is angle theta will be A tan 2. A tan 2 px comma py, px comma py. By the way, if this angle over here generally is defined as arctangent of px divided by py, right? Right? Sine over cosine. But this will give you a wrong answer if you are not. Never. I will forget about A tan. I will forget about A tan from now on. I'll always use A tan 2 our reference angle. Okay? If you don't have your calculator which doesn't have A tan 2, use the tangent to find the reference angle. Okay? It will always work because it will always be less than 90 degrees. You know reference angle is always less than 90 degrees, right? Plus or minus 90 degrees, right? Right? So you will never go wrong finding the reference angle. From there you can find the angle. Or if you have MATLAB or calculator which has A tan 2, use A tan 2. So in this case, what would that be? If go home and try MATLAB, both A tan and A tan 2, what is Px? Minus 0.8. What is Py? 0.6. Okay? It means you are in the second quadrant. In second quadrant, your angle should be between 90 and 180. Guaranteed, right? If you are in second quadrant, always sketch the vector. Always sketch that. You will never go wrong. You know it angle better be between 90, and if the calculator gave you wrong, you will know I got a wrong answer. You're smarter than the calculator. Okay? If you are in the first quadrant, it better be between 0 and 90. If you are in the third quadrant, better be between minus 90 and minus 180, right? So better always know that what the answer should be. So the calculator lied to you. Calculator never lies. You put the wrong information in there, right? Garbage in, garbage out, right? So if you put it wrong, sometimes you press the keys wrong, right? And you just don't consider that to be a guard giving you the right answer. Always know what you're going to get, right? Okay? So in this case, the answer should be 143.2 degrees. So your answer come out to be vector in the polar form. All right? You understand? Okay, so where do we use vectors? I only have about 5-7 minutes. Let's use that in a real application. Okay? You vacuum clean. You help your parents vacuum clean? Okay, so let's use the vacuum cleaner. Okay, when you vacuum clean, you probably never realize that you are applying a force, right? At certain angle, right? Okay, so if I want to know the component of that in the x and y direction, I should be able to find that. So let me draw that. I'm not very good in drawing, okay? So I'm going to have a line drawing. So this is my vacuum cleaner. Okay? Is that good enough? Is that good enough? That's my vacuum cleaner. Let me put a handle to that, okay? Now it's good enough, right? I can, okay. So what you're given is you are applying a force to that, right? In that direction, right? Okay, whatever direction you're applying the force. So let's say this angle with the horizontal is 40 degrees. It could be different, whatever angle you're using. So you can find out what's the optimal angle you should be vacuum cleaning so you don't put too much force in there, right? Right? Okay, anyway, so let's say this is given to be 20 pounds, right? So that's my F. That's the magnitude of the force. So F then, this is a vector F, is what? 20 angle of what? 40 degrees? If I say that's wrong, And by the way, always you put the units in there. I say that's wrong. You will agree if I say wrong? What's wrong in that? Negative. Why is negative? So let me redraw that. Let me redraw that triangle. So I'm saying, I'm doing this, right? This is my F. So this is my X direction. That's my Y direction, right? Agree? So I told you counterclockwise to be positive, clockwise to be negative, right? So this is going to be a negative 40 degrees. So always know what direction you're doing that, okay? All right, so I want to find the component in the X and Y direction. Okay, so what's the force in the X and Y direction? All right, so let's do that. All right, so we know, let's say Fx. Oh, by the way, this is 20. So X direction is cosine, right? So we'll say 20 cosine of minus 40 degrees, right? Angle is minus. You know cosine of minus theta is same as, in this case better be positive, right? Cosine of minus theta is cosine theta. So this will come out to be, if I do that, this is 20 cosine of 40 degrees. I know my time is almost up. So 50.3 pounds. Okay, let me do one more thing. Let me find that if you put the right angle there, in this case, is, you know, minus sine of minus theta is minus sine theta, right? And if you do that, this comes out to be 12.8. It gives you minus 12.86. Now, let's talk a little bit about that. Let me stop right there, but let me point this. Can force be negative?
Yes.
Negative?
No. No.
How can that be a negative force? Force can never be negative. What it is saying, the negative sign says it's in the negative y direction. So that's what is pointing. So really representation of that will be F is equal to 15.32 in the positive y direction and 12.86 in the negative y direction. And you put the units in. Don't forget the units. Let me tell you, I'm not grading your exam, but if you don't give the units, 1 point taken out for just not giving the unit. So why lose points, okay? So I try to give all the units. Thank you. I'll see you again maybe in a couple of weeks, okay?